Hello, welcome to a new Design Automations podcast series. We have been driving thought leadership ideas around system design by discussing design automation related challenges with our esteemed panelists. My name is Krishna Banka, your host for this podcast. I have over 2 decades of association with semiconductors and electronic design automation industry. My guest today is Richard Powlowsky. Rich is a senior director responsible for strategic accounts and the US government business at Siemens EDA, part of Siemens Digital Industry Software. Siemens EDA has evolved from the Mentor Graphics acquisition by Siemens back in 2017. Welcome to the podcast, Rich. Please introduce yourself to our audience. Tell us about your professional journey.
Thanks, Krishna, and thanks for inviting me. My journey actually goes back to the mid-'80s. I was an electrical engineer, and my first role was in the U.S. defense industry, actually. I later got involved in EDA in a startup doing cycle simulation and as an application engineer, and eventually got into sales and ran their sales organization. We actually licensed that technology to a company called Mentor Graphics at the time. I later joined Cadence Design Systems. I was there for about 18 years up until 2017, responsible for some of their key relationships such as Global Foundries, IBM. I also had the automotive sector and bringing Cadence platforms into that sector. Most recently, I joined Siemens EDA, which formerly Mentor Graphics. I joined them back in 2017, and I'm handling some of the strategic customers. And a couple of years ago, I actually picked up the responsibility for our U.S. government business, which includes the Department of Defense labs, Department of Energy labs, NSA, DARPA, what I would call some of the research and prototype activities that occur before programs actually get into the active large primes that the Department of Defense is contracting.
So that's I must admit that the kind of work that you're doing sounds really exciting. So I do understand that you are actually doing a lot of work on the defense and aerospace industry as well. So what are the major challenges in defense and aerospace that you see today?
Yeah, so by the way, I'm not an expert, but I've been asked to try to understand those challenges by Siemens did. I'm part of Siemens Digital Industry Software, and what I look at is if you look at you go back to when I started in the defense industry. I think a lot of my peers getting out of college in the 80s were looking into defense because that's where the jobs were. It was almost before the internet almost. So eventually a lot of folks migrated to the commercial world when you saw the advent of the Apples, the Googles, the Facebooks, as well as even before that, the networking players like Cisco and etc. So there were significant opportunities in the commercial world that I think drew a lot of the defense capabilities and skill sets out of defense. If I actually look at some of the core challenges that we see in defense, I think the first challenge is finding the best engineers. The best engineers still want to go to Google, Apple, etc., Qualcomm, NVIDIA, you name it. There's no shortage of places for the best engineers can work on leading edge technologies. I think that's one of the big challenges. I think as far as the ability for the United States, as an example, and our allies to stay ahead of our adversaries when it comes to first strike or capabilities and the resilience in the war fighters. I think a big challenge is obsolescence. A lot of the government funding, if you look at it, it's actually goes towards what they call sustainment as opposed to acquisition.
Right.
Because there are only so many new programs that come up, but there are many, many, many more programs that are sustained for decades. And, one example that I think most people understand, the B-52 came out in the 1950s, and the B-52 is still getting upgraded. It's been 75 plus years. They expect it to be a platform that lasts 100 years. So aerospace and defense has a very unique set of differences than you would find in, for example, automotive or consumer, and that is longevity.
Right.
So those are the major challenges I see. Is how do you replace obsolete parts? How do you upgrade electronic systems? Because if you think about, mechanics might not change. The B-52 is still a B-52. I'm sure there are a few parts that are now carbon fiber or whatever, but the electronic systems need to go from 3G to 5G to whatever, the radar systems and the leading edge. What keeps these programs alive is really the electronic capabilities. And if even today, one of the things that surprises me is the Department of Defense, for the new requirements that they have, may not even require electronic specs. So, what you get for specs from the primes is, what the RFP asked, what the request for proposal asked for. And, typically they're looking for a system, and the electronics piece might be, if you look at specifications, it might be delivered as a PDF file.
Right.
And, a PDF file is a little tough to work with when you're trying to build the next generation of the piece of electronics. So I believe what will happen over the next 10 years and what I actually see starting to happen is, the idea of model-based engineering, virtual models, delivering electronic specs that can be proven and reused. So I think over time, you're going to find that the Department of Defense doesn't necessarily have to go back to the big primes like Raytheon or Northrop Grumman or BAE for an upgrade. They may, at some point, they will have the electronic specs. They can farm out to try to get the latest and greatest of the next generation of electronics. So I think that's the big, to me, the big issue is obsolescence and trying to become more efficient as the new capabilities are developed.
Right. So I think that's a wonderful summarization of how the aerospace and defense industry actually is working out. On one side, I think you very clearly described the way the industry has been evolving and where it started from. So what were the pertinent issues which were seen, and how are those issues still manifesting, and how is the industry trying to evolve? So I think the kinds of issues that you captured are actually very pertinent. If you look at any long life cycle kind of electronics setup, any such industry will have those kinds of issues Obviously, the degree of those issues will vary depending upon the industry that you're targeting. So specifically, if let's say we talk about Siemens EDA, so what role is Siemens playing in being able to help out with these challenges?
Yeah, that's a great question. So, interestingly enough, I spent a lot of time at a couple other EDA companies, a startup and a large player. And Siemens acquired Mentor Graphics back in 2017 to try to fill out the electronic capability in the digital industry software product division. So one of the key differentiators I see with Siemens is not just trying to solve the electrical problem, we'll call it the problem within the chip, or the board or the package, but expanding that out into the system level. And when I say system, we think of heterogeneous, multi-chip modules or heterogeneous 3D heterogeneous systems. They are systems. They're yesterday's board is today's 3D heterogeneous system, which could contain a baseband module at 5 nanometer. It could contain photonics. It could contain in a separate IC. It could contain stacked HBM for memory. So you're really looking at a 3D system. How does that system behave thermally, mechanically, from a stress standpoint, as well as an electrical standpoint and a physical standpoint? So, Siemens is really looking at how do you put all the pieces together to be able to deliver complete solutions at the electronic system level. And it goes beyond there, it goes into manufacturing, et cetera. And by the way, having been in EDA for so long, most large companies, enterprise accounts, they use best of breed methodologies. So they're typically, it's a startup that might use one EDA player or 1.5 EDA players. The enterprise guys use best of breed. So what gives us an advantage is we do have all the tools, we can put them together.
Right.
And if you look at the future in our industry, it's really about integration. It's not necessarily about developing new tools. It's about integrating the current tools and finding ways for them to work on an in-memory basis. So today, what I see with, we'll say 3D heterogeneous systems, you have script-driven solutions where you check the thermal, you check the mechanical, you check the electrical, you circle back. Right. I think 5 years from now, and maybe sooner, you're going to see more integrated modules where you can bring in memory solutions that are allow you a quicker closed loop and the ability to actually prototype these systems, closer to a sign-off capability, much earlier, as we call shift left, I guess.
Yeah. Well, defense and aerospace have always demanded mission-critical application of electronics and automation. That's for sure. Yeah. And Siemens is at the forefront of technology, pioneering the creation and adoption of design and automation solutions for this industry. Well, wonderful conversation, Rich. Thank you again for your time.
Krishna, it was a pleasure anytime. And thank you for the consideration.
Thank you. So that concludes our podcast. Any topics you would like us to cover, please leave a comment. Thank you everyone for your attention and have a great day.